In this lesson, we will talk about how to take an equation that is in standard form and write it into vertex form. We're going to use a method called completing a square. And this method has a few different ways of teaching it, and some teachers do it quite a bit different than I do. So if you know their method and that's the method you like and you get the same answer, then you can go ahead and use that method. But I have found that this method is quite a bit easier to understand and to a lot less steps. So we're going to go ahead and talk about how we can take the equation that is in standard form and convert that to vertex form so that we can graph the parabola on a coordinate plane. Before we begin talking about vertex form, I want to take a second and review standard form. As you recall, equations that are in standard form, that's when the x squared, the quadratic part of your equation, is first, with the a value being the coefficient of the x squared. And that's followed by the bx, b being the coefficient of x, and the c value, which is the constant of the quadratic equation. In order for a quadratic equation to be considered in standard form, it must be set to 0. And the reason that we have that is because when we solve quadratic equations, we're looking for the x-intercepts. And anytime we have an x-intercept, our y value will always be 0. So that 0 is representing the value of y. And then therefore anything that we get would be the x-intercept with x, whatever the x equals is the value of where it's located on the x-axis, and the 0 being the fact that it's an x-intercept. Now, what we're going to do today is we're going to actually convert our equations into vertex form. And the purpose of the vertex form is that once an equation is in this form, you can easily look at it and just tell what the vertex is. And here I have an example of vertex form where we have a times x minus h squared plus a k, and notice that it's still to 0 because all I have done is taken the numbers in standard form and switched them around and put them in vertex form. One thing I want to point out here is that we have an a value, and this a value is the exact same a value of standard form. So if I have an equation that the a value in standard form is 3, once I convert it to vertex form, I still should have an a value of 3. The other thing I want to point out is we have a couple different variables in here, unlike standard form. We have an h and we have a k. The h and the k, when you have an equation you put in the form, will actually be numbers, and those numbers that are there are representing the vertex. So anything that is in the location of the h in the formula will be the x of the vertex, and anything that's in where the k is will be the y of the vertex. Another thing that I want to point out are the operations. Here I have a minus sign and here I have a plus sign. Now the minus sign is, because that's in the formula, that is saying that the h, whatever that number is for h, if there's a minus sign, the h would be positive. So if I had something in there like x minus 2, the x of my vertex would be positive 2, not negative 2, because I need to have a negative in order for the formula to be true. If I had something in that area x plus 2, so here I had the x and then this was a plus 2, then my, because I don't have a negative sign in the formula, that would mean my x is a negative 2. And we'll talk about that as we're working. The same thing goes for the k. I have to have a plus sign in my formula. So if I have a plus, whatever that value is for k that's there would be positive. But if there was a minus sign right in that location, then I would have the opposite, because the operation is opposite. The value would be opposite. So if I had something, the k value was a negative, if it said minus 7, then that would mean my y value of my vertex is 7. So this h and this k are the same as the x and the y of your vertex. When we solve a quadratic equation by completing the square, what we're actually doing is we're taking the quadratic equation, and it's originally in standard form because we always start in standard form, and we change that equation to vertex form. So whenever you hear someone talking about completing the square, what they're really doing is they're just putting the equation in vertex form. Now we're going to go ahead and convert our equation. And the first thing we need to do, the very first step, is we're going to take the quadratic equation and we're going to put it in standard form. So we need to set that equation to 0. Here I have x squared plus 7 equals 8x. The 8x needs to get on the other side, on the left side of the equation, in order to set that to 0. So I'm going to take that and I'm going to subtract 8x from both sides so I can move it to the left side of the equation. And when I do that, I'm going to end up with x squared. Now I have minus 8x. That 8 is my b value, so that needs to come next, plus 7, and that's now going to equal 0. And when the equation is set to 0, that's when we know that it's in standard form. The next step is I am going to identify my a and my b value. Here my a does not have a coefficient, nothing that's showing, so I know that coefficient is 1. And my coefficient, my b value, is going to be negative 8, my coefficient of just x. I'm going to use this information to find the vertex using the vertex formula. In previous lessons, we learned how to use that formula, the negative b over 2a. So I'm going to take my b, which is a negative 8, and I'm going to have negative 8. So that's a negative b over 2 times my a, which is 1. Now a negative 8, a negative negative 8 makes a positive 8, and I'm going to divide that by 2. And negative 8 divided by 2 is 4. So my x value of my vertex here is 4. Now to find my y value, I'm simply going to plug my x value back into the original equation. So here I have my original equation. And so now I'm going to have y is equal to my x squared. Now I discovered my x is 4, so I'm going to have 4 squared minus 8 times 4 plus 7. 4 squared is 16 minus 32 plus 7. 16 minus 32 is going to be a negative 16 plus 7, and that's going to make a negative 9. So my h value, or my x of the equation, h and x are the same thing, my h value is going to be 4, and my y value, my k, will be negative 9. Now that I've found my h and my k, my vertex, I'm just simply going to plug it into the formula. I need to make sure I plug that a value in from that original equation, and then I'm going to plug in the a, the h, and the k. And I'm going to plug them just like the formula is. So my a was 1, and then I have x minus my h value, which is 4. Don't forget that squared. A lot of people forget that. Plus, I have negative 9. Now, if I don't want to write plus negative 9, because that's kind of sloppy, I need to remember that the plus sign is part of the formula. But if I put a negative 9 in there, I can just write minus 9. Because I'll know when I look at it that there should be a plus. And if there's a negative, that means it's the opposite, is equal to 0. One thing that I'd like to point out at this time is that we use completing the square and quadratic formula. You can use these to solve any equation. Most of the methods that you've learned so far have particular kinds of situations in which you can use the method. For instance, GCF, you need to have the greatest common factor in there, and usually on that you have an A and a B value, but you don't have a C. In double bubble, you would get two answers that come out to be whole numbers, or rational numbers, I should say. Sometimes there's a fraction, but they're at least rational numbers. But sometimes you're going to have equations where you try to multiply things together and you can't get the answer that it's asking for. In other words, if you're going to use double bubble for example A right here, we would have to come up with two factors that would be um, positive 36. And actually, this one you could use doing double bubble because you could have -6 and -6. But sometimes it doesn't work out so perfect. And in that case, what we have to do is we use the vertex form. And a lot of times we'll get irrational answers using this, completing the square and putting the equation in vertex form. So let's practice with these examples here. To start off with, I need to put it in standard form, and my equation is in standard form. So the next thing I'm going to do is identify my A and my B value. So here my A value is 1, and my B value is -12. I'm going to find the vertex of my equation by using the vertex formula, negative b over 2a. So I have negative, -12. I always just move that negative right to the top where the b is. And that's going to be over 2 times 1. Negative -12 is going to be a positive 12 all over 2, which makes my x value 6. I'm going to take my 6 and plug it back into the equation. 6 squared minus 12 times 6 plus 36. Oh, I did put my 6 in. I put x squared, so let me fix that real quick. That's 6 squared. 6 squared is 36. Minus 12 times 6 is 72. And that would be plus 36. 36 minus 72 will be a -36. Plus 36 would be 0. So my y value here is 0. So I'm going to go ahead and use this other white space. I'll erase it later. But now I'm going to plug this into the formula. I know my a value is 1, so I really don't need to write that down into the formula. So let's just write the formula real quick. X minus h squared plus k. So I don't need to write my a because it's just 1. X minus my h value is 6. And it's a positive 6, and the formula is supposed to be minus, so I leave that minus. And then my k is plus 0. And that would equal, of course, 0. Now, if I don't want to write this 0 right here, that's okay. I can just write x minus 6 squared equals 0. So that would be example A. I'll give you just a second to write that down or look in your notes and compare it. And then we'll go ahead and erase that and do example B because there's not really a lot of space today. You might want to pause it at this time if you need to. Okay, now for the next example. Again, we're going to look to make sure it's in standard form, which it is. We're going to identify our A and our B value. Our A again is 1 and our B is 3. We're going to put that now into the vertex formula. So that's going to be our negative b over 2a, which is going to be -3 over 2 times 1. So we have -3/2. A lot of people, they don't like the fractions, but the fractions are just part of the equation, so we have to deal with those. So let's go ahead and plug that back in. -3 squared, or over 2 squared, plus 3 times negative, let me write that a little better, sorry, 3 times -3/2 plus 5 is equal to 0. When I square -3/2, I'm going to just square both the numerator and the bottom and the denominator. So I will have the negative and the negative will just square to be positive. So I'm going to have 9/2, or I'm sorry, 9/4 And then I will have 3 times negative 3. So that's going to be a negative 9 halves plus 5 equals 0. Now, in order to make my math a little easier, I'm going to just make common denominators. And I'm going to change the 0 to a y because it will make more sense that we're solving for y. So I have 9/4. That's going to be my common denominator. Minus, I'm going to put my 9 halves in with a common denominator of 4. So that will be negative 18/4. And I want to put my 5 with a denominator of 4. So that would be 20/4. And again, that equals y. So 9/4 minus 18/4 is going to be negative 9/4. And then if I add another 20 to that, I will have 11/4. So my y is going to equal 11/4. So now I'm just going to plug this back into the equation. Again, my x value is just 1, so I don't need to worry about that. But I'm going to have x minus my h. My h here is negative 3/2. It's right here. I have a negative 3/2. And my formula calls for a negative sign, but because I have a negative number, I'm going to make that a plus 3/2. And again, that's squared. That will be, a lot of people will make that mistake of forgetting that squared, so be very careful. And then this next operation is plus 11/4. And that, of course, is equal to 0. Go ahead and take a second. If you need to compare this with your notes or you need to write this down, you may want to stop the video for just a second to freeze everything. And I will erase it and then go on to the C problem. Okay, we're going to begin working our last problem, and this one's has a little more to it because I actually do have an a value this time. So let's go ahead and identify our a value, and that is 3. And our b value is going to be 8. Again, we're going to use the vertex formula. And I have a tendency to move that negative up to the b, so it's just the negative fraction, but it doesn't matter where it's at. So now I'm going to have a negative 8 over 2 times my a value, which is 3. And that's going to be a negative 8, and 2 times 3 is 6. So it'll be negative 8 over 6, which 2 can go into both of those. So I would have a negative 4/3. And that's my x. My x of my vertex is negative 4/3. I'm going to plug that back into the equation. And I will have 3 times my x squared. So I have negative 4/3 squared plus 8 times my x value, so negative 4/3, and that will be plus 4 equals 0. So the first thing I'm going to do is my exponent. So I have a 3 here, and I'm going to square my x, my negative 4/3. So I'm going to end up with 16. That negative goes away, ninths. And then I have plus 8 times negative 4 would be a negative 32 over 3. And I'm going to put that in parentheses. And then plus 4. All right, so I need to simplify this first fraction with this coefficient of 3. I can actually cross-reduce here. This 3 is the same as saying 3 over 1. So I can divide 3 into both the 3 and the 9. So this will become a 1, and this 9 will turn into a 3. So if I rewrite this equation, I'm going to have 16 over 3 plus negative 32 over 3. And I'm going to convert my 4 to have a denominator of 3. So to do that, I need to multiply 4 times 3, and I will get 12 over 3. And that just is going to equal 0. So 16 plus negative 32 is going to be a negative 16. And a negative 16 then plus 12 is going to be a negative 4. So I have the denominator of 4, but I'm going to have a denominator of 3. Negative 4 over 3 will be my y. I'm going to continue putting this in vertex form, and I'm going to move over to the side over here just for room purposes. I have my A value, which I identified in the very first step as 3. And my H value, which is the next thing I'm going to have to put into the vertex form, that is going to be negative 4/3. And then my K value is negative 4/3. So I'm going to plug those into the equation with 3 times x, and it's supposed to be minus, but I have a negative 4/3, so I can write plus 4/3. Otherwise, I would have to have a minus minus squared. And then this is supposed to be a plus, but because it's a negative, I can write negative 4/3. Again, you can just take a second and pause the video if you need to so that you can write these steps down. Um, both of these, in both situations, or in all three situations, um, you could have probably done these equations using a different method. And I can tell that because you come out with rational solutions. You didn't have to approximate anything. But a lot of times you have to use completing the square because it's just not, it just doesn't come out. Double bubble won't work and bottoms up won't work. And so the completing the square, putting it in vertex form helps make you to get an answer that is accurate, and usually will have a radical in it. The next lesson that follows this is how do you actually solve the equations so that you can graph them. Like in this, you're just putting it in vertex form. But now, once it's in vertex form, what do you do so that you can graph that on a coordinate plane? And so that would be the next step after this lesson. Just to review real quick, it's important that your equation is in standard form. If it's not set to 0, you cannot use this form because you cannot identify your A and your B values. Once you identify your A and your B values, you just use the vertex formula to find the X, and then you use the X to find the Y, and then you just plug everything into the formula.